moving, not moving, moving, not moving, moving, also moving, definitely moving. What makes things move and other things not move? Something that is moving has a force that has acted upon it.
The Force?
Yeah!
No, not the force of forces that are natural in our world. Yeah, they're friendly forces.
Oh.
You see, a force is a push or a pull.
A push or a pull?
Yes, you see, everything that moves has a push or a pull behind it, has a force that makes it move. So whether it's carrying books, sliding down a slide, riding a bike, or combing your hair, if something is moving, a force has been acted upon it. One way that things move is by an applied force. An applied force means you are applying a force to an object. I use a force to open the mailbox, a pull. I use a force to close the mailbox, a push. I use a force to open the car door, a pull. I use a force to shut the door, a pull. I can apply a force to this football to throw it. It'd be a push. To use this wheelbarrow, I need to apply a force. I need to apply a pull to pick it up. And now I'm going to apply a push to move it. To climb this ladder, it's going to take a force, a pushing force. To pick up this tub, it will take a force, a pulling force. To move this lawnmower, it takes a force, a pushing force. To move this dirt, it takes a force, a pushing force, sometimes a pulling force to move the dirt. To ride a bike, you need to put a force on the pedal, a pushing force. To put this nail in this wood, I have to apply a force with this hammer. It would be a pushing force. To take this nail out of the wood, I would need to use a force, a pulling force. Oh, that gives me an idea. I should tell you about gravity. This is good to eat, though. Gravity is pulling on everything. Everything, even me, you, everything. Try to resist gravity. You can resist gravity a little bit. You can hold one leg up. For a little while you can, but not very long. I can try to put both legs up in the air, but I keep coming back down because gravity wants me back to the center of the earth. Fortunately, the ground stops me from going to the center of the earth, though. See how long you can hold your arms out. After a while, they get tired. They're getting tired because gravity keeps pulling on you. And after a while, it's hard to hold your hands up. The weight of an object is force of gravity pulling on that object.
Oops. I better lose some gravity.
Here are some ways that gravity is seen in our world. Some things can resist gravity, like birds flying, hot air balloons rising, jet airplanes flying. My buddy Ron Jackson is a magician. He can defy gravity. He's an amazing watch. Sir Isaac Newton was born in 1642 and died in 1727. And during his time, he developed 3 laws of motion. The first law of motion is an object at rest will stay at rest, or an object in motion will stay in motion unless acted upon by a force that is unequal, meaning it is able to stop it or move it. First law of motion, an object at rest will remain at rest unless acted upon by a force. When you coast on a bike, that's the first law of motion. An object in motion will remain in motion unless acted upon by a force. Whoa! The first law of motion states an object in motion will continue at motion unless acted upon by a force. When I throw this football, it should go forever and unless something stops it. In this case, gravity. The second law of motion is easily seen by the formula F equals ma. That really means F is force, and the force equals the mass times the acceleration. If you take an object's mass and multiply it by how much it accelerates, you will know how much force you need. Another way to look at the second law of motion is if an object has more mass, it will take more force to accelerate it. If it has less mass, it will need less force to accelerate it. Lots of ways to look at the second law of motion. Now I have to figure out how to get out of here now. I can find the second law of motion in this. If I apply a greater force, the acceleration of the nail into the wood would be greater. I start out with a smaller force. So a lower force, the nail doesn't accelerate that fast. When I do a greater force, the nail will accelerate faster. I'm glad my thumb wasn't in the way. We want that to happen again. Ow. To pick up the smaller tub, it should take less force, because the second law of motion states the less the mass, it will take less force to accelerate it. The big tub, look how easy it is. Let's see if that's even easier. Oh, wait a minute. This one must have more mass. It has a brick in it. This one's empty. So the more mass, the more force to accelerate it. Second law of motion. Very easy to move it with nothing in it. Now I have some things in the wheelbarrow, and now it has more mass. So the second law of motion states if I have more mass, I have to apply more force to accelerate it. Sometimes I have to move a wheelbarrow on a wheelbarrow. Takes a lot more force. I'm pushing on this tree, that's a force. But the tree is not moving. And that's because the tree is pushing back at me. If it wasn't pushing back at me, it'd move over. That's the third law of motion. For every action, there's an equal and opposite reaction. My action is pushing on the tree. The reaction, the tree's pushing on me. Thanks though, you've been a great tree. Thanks for helping out. I'll give you a lot of water. When I climb this ladder, it's the third law of motion. For every action, there's an equal and opposite reaction. I'm going to push on the steps of the ladder, and the ladder then will push back at me. If it didn't push back at me, my foot would go down lower, but it doesn't. So the ladder steps are pushing back at me as I push on the ladder steps.
Let's make balloon rockets. All you need is balloons.
Then you need string and tape.
And then you need straw.
First, you're going to tie the string to something.
Or you can tie a string to a chair. Before you tie the other side of the string, put in the straw first. Put the string through the straw and tie it to another chair. Then you tape the balloon to the straw 2 times. Put the tape in 2 places of the balloon. You let go. Balloon rockets, ready, set, go. Balloon races, ready, set, go. Let the race begin.
Why does a balloon go when you let go of it? This is what happens. It's actually on the third law of motion. There, for every action, there's an equal and opposite reaction. This is kind of cool. The balloon will be right here. Riley is going to be the balloon. And Caleb is the air that's in the balloon. The air wants to leave the balloon. So watch as Caleb is going to push Riley so he can get out of the balloon. Watch what happens. Go ahead. Notice how Caleb slides this direction. The air leaves the balloon and the balloon flies off. That's why the balloon goes. Really?